Good afternoon and evening, everyone. Welcome to our October 2023 Tech Talk. My name is Don Linford. I'm the Director of Innovation Ecosystems here at Aspire. We're glad that you could join us today. We have a couple items on our agenda. We'll have a presentation in just a little bit from Dr. Alexander Kuhl, but we'd like to give a bit of an update of our highlights on what we've been doing here at Aspire the last month or so, and also introduce something that will be coming up here fairly shortly related to a member dashboard. So first of all, we'd like to thank everyone who participated or had the chance to participate in our annual meeting last month. Just so everyone knows, the National Science Foundation did come and do their site review of Aspire, and we're very happy to say that we received a top rating as one of the ERCs. So that was a great outcome for us to have that. I don't know if Yvonne, if you want to mention anything about that.
We have Regan here too that can.
I can't see who's on, so I apologize. Regan or Yvonne, both,
Yes.
if you want to say something, that'd be great.
Regan, go ahead.
I think you already said it, Don. So thanks for all the help, and excited for the involvement that we had from industry and innovation board, as well as all of our participants. But we had a good discussion with NSF. This was our third year review. They're very pleased with the progress that we've made, and they're particularly excited about the progress towards societal impact, meaning that our concepts, technologies, best practices, thinking are moving into society. And much of that was gauged based on the success of our various engagement programs with our IIB, including these tech talks. So anyway, it was all seen very positive, and they're excited to visit us next year. Next year will be just a quick highlight of what this means. They have different levels they can provide. The top band review is what we received. What that means is no required changes. We're approved to continue into next year. They're going to be giving us a formal report with feedback and some suggestions, and we have to respond to our thoughts on those suggestions. But there's nothing required for us to change. So it's a very good place to be. Next year is our year 4 review, which in NSF's world, they're going to be considering that our renewal year, which means next year is when they're making the decision whether to provide the additional 25 million for the following 5 years, for our last 5 years of the 10. So a very important year coming up, and we have a very strong path and momentum coming out of this year. So very excited to see this coming, and very strong review from NSF, and thanks to everyone for your participation. NSF is noticing it.
Thanks, Regan. Are we good, Yvonne, or would you like to say anything?
No, I just wanted to say and reiterate something that Regan said, that the participation from the industry, our innovation partners, and all the work that, Don, you have laid the path for our success with these collaborations. So thank you all.
I appreciate it. And as part of our annual meeting, we did have an Industry and Innovation Day, which was on the Thursday. Many of you had a chance to participate in that. It was, I thought I had a lot of energy in the room, had a good chat around the tables, as like someone said. We are in the process of consolidating the notes. We've had a couple of members come to us and say that asked if we could share the chat GPT, kind of what I call the dirty notes that we did on the day. We're more than happy to share that. We do have a student from Purdue who's helping us also take the detailed comments that were done and kind of create a little more analysis on top of it. We met last week, and I think it'll be probably a week or two still, but then we'll be able to provide that. And that will be kind of the chat GPT comments that were aggregated on the day. It'll also include the raw notes that were taken across all of the different tables during the sessions, and with a little bit of analysis that kind of comes back to it around key issues throughout the day and how that reconciles back to our annual report. And speaking of which, as part of our annual meeting, and what we were able to do is we were able to share with members, and we're in the process of sharing this much more broadly, but we were able to share with individuals our annual report. So if you've not received a PDF yet of our annual report, please reach out to me, but we're in the process of distributing this across our membership and members and partners. This is a PDF file of it that you'll be receiving as a link if you've not received it as of yet. We use that throughout the site visit with the NSF team, but we also used it on the day of our Industry Innovation Day as well. So we're excited about it. This is something that we've together, which we hope will be really in a way that members and others can look at this and see all the great work that we're doing as a center. It has something that looks quite familiar to people who come from industry or other areas where they create these, what we call glossy annual reports. So it has a message from our directors, from our Dean's Council, our Executive Advisory Board, and others. The thing that we're really excited about it is the table of contents. When you receive the file, you can actually go down and pop up the projects. And even though we've had this available in other formats, this annual report really gives us the ability to see exactly what we're doing on projects, and also how we're linking those to our short, medium, long-term goals, where that's going to take us down the road, where we'd like to be coming up to year 4. It also highlights some of the technologies that we're working on and some of the status of where that is. So again, we're very excited and happy about this. I don't know, again, Regan, if you wanted to mention anything, or Yvonne, about the annual report itself.
Yeah, nothing more than please read it. We put a lot of extra effort into making this digestible and hopefully useful for you. And we're going to leverage this as a platform or a guide to even further improve next year. So we're also quite interested in feedback. But hope you enjoy, and please let us know if you have additional thoughts and questions.
Yeah, I absolutely encourage you to read it when you get it. It is kind of a bit of our canon that we're using in the center. It's something that we hope to leverage in the future in other opportunities. And Regan put in the chat here, if you haven't seen it, also hot off the press, our Professor Matt Olin from Purdue, who's our engineering workforce, one of our directors, has been inducted into the 2023 ASEE Hall of Fame. So congratulations, Matt. That's a great accomplishment. So appreciate that. Now, moving quickly, besides our annual meeting, what we're trying to do with our members in the annual report is lay out tools in ways that we can greater interact with the center. So coming shortly to you is an upgrade to our industry and innovation website, where we've created a dashboard. So many of you don't have logins, and don't worry about that for right now, as you'll get a chance to figure out what we'll be doing with that. And soon you'll get a login, but you'll also see that once you get your new login, it'll bring you to, and you'll have the ability to log into the new member dashboard. And within the member dashboard, we're creating a space where we can have greater collaboration across the center and among industry and innovation members. So we'll have banners, but we'll also see we have collaborate with members. You'll see that we have a calendar. One of the things that we will have is a member book. And just by way that you'll see that this is where many people say, who are our members and what do they do? Who can I talk to? We'll make this available. We'll use ACOM as an example. It's not 100% done. We'll be finishing that between this week and next, but you can see here is the ACOM, what it does, what their website is, LinkedIn, plus who's the primary contact. What we'll be doing though is, as we reach out to you, you'll have an opportunity as members to, like many other places, to update your profile. You can put in what you want your contract to be. You'll be able to change, if there's feedback on the about related to your institution, we can work with you on that as well. So for us, it's something we're happy about. That soon we'll be able to share this. We'll give you an opportunity to see who the members are and have a much more granular opportunity, other than just seeing logos on a PowerPoint, see exactly who these entities are and what they're doing and who you can talk to. An opportunity for collaboration. Other things you'll notice here is we will have, again, tech talks available, and they'll be updated. Here as part of that, something that's the library is available will be there for you. So collaborate with members will be there. There'll be calendar items that will be relevant to the center and to the industry group as well. And things that we're working on that will come shortly, as we're working with Carolyn and others, including our student engagement committee, is we do want to have a student talent book. And this is just a sample. Please don't focus too much on this, because this is work in progress, but you'll get a chance to see that we will have the ability for you to access talents through here, see what they're working on, the projects and also be able to sort against it as far as what students, their degrees and other things. That's one thing we're working on that will be coming out with that. And then we do have explore our research, which we're working on a members news portion, but we do have publications that are available that will come out with it as well that you can sort and search on. And we've also made available currently today our Aspire IP that pulled you out into, unfortunately, this is a format we have, but it's still good, which is a PowerPoint, lets you see really what's available there. So these are coming within the next 30 days. We hope to have this out by the end of November as we head into the next calendar year. But these are tools that we're looking to have available for members. And obviously some of this will be vetting with you as members and others and getting your feedback on it. So hopefully that's clear. If there's any questions, more than happy to answer a question or two if you have one. If not, great. Well, our presentation today is from Alexander Cole. Let me just. So we have the great honor of having Dr. Alexander Cole. He's the Director of Research at the Center for Electromechanical Engineering. He's at the Frederick Alexander University School in Nuremberg, and it's the School of Engineering, Department of Mechanical Engineering, Institute for Factory Automation and Production Systems. So here the acronyms are FOPS-FOW that we use. He's head of research of the research center, where it's made up of 21 scientists, and they work in the area of administrative and technical support. The field of research that he's had in the past is he does teaching, and he relates to electric motor production technology, inductive charging, electric charging pad production, electric road system production. He's also a member of the executive committee and chair of FOPS, and a member of the faculty of the board of the College of Engineering. And we're excited to hear what are the great things that they're working on in Germany and Bavaria. So at this time, I'll turn it over to Dr. Alexander.
Thank you very much for the introduction, also for the possibility of presenting here. I just tried to get it into the presentation mode. I think it worked. Okay, yeah, thanks. Yeah, as introduced, I'm head of the research group, which is about electromechanical engineering, and I want to present you what we as an institute are doing in the we call it E-Road here, in the E-Road Center production in Bavaria. I just want to give you a short overview. I hope everyone can see the slides in full mode, if not screen. Give you a short overview about our university and our institute, the motivation and what we are researching on, and the next step, or the last slides, will be about our so-called E-Road Center and the cooperation between us and the Aspire network. So our university is quite old. It was founded about 275 years ago in 1742. Since 1743, it was also located in Erlangen. I tried to place a small dot on the map of Europe and Germany. So we are in the south of Germany. And since the 1960s, we're having also a School of Engineering. And in 1982, our Department of Mechanical Engineering, as well as our institute, was founded. The structure of the university, just in a few words, we have got 5 schools: the School of Engineering, I already mentioned, a School of Science, a School of Medicine, a School of Law, and a School of Humanities. And within our School of Engineering, we have got 6 different departments. The youngest is the Artificial Intelligence and Biomedical Engineering. And one of the oldest is the Mechanical Engineering, where our institute belongs to, with 10 other institutes. So the focus of the Mechanical Engineering in Nuremberg, or Erlangen Nuremberg, is set on production technologies, as you can see here, also on the names of the institutes. And our focus is set on the factory automation and production systems, FAPS. The university itself has about 40,000 students. We've got 60,000 employees. In this case, our PhD students are mainly also listed as employees because they have a contract here at the university, and we have got about 600 professors working for the University Erlangen-Nuremberg. So just for what we are doing at our institute, so we do the factory automation and production systems for the production and assembly of mechatronic products. Just a few examples: we do electronic production, so I think everybody knows the screen electronic plates. So our part is there, how to produce them, how to produce them with new technology, with new circuits, maybe also with new topologies like foils or three-dimensional forms and so on. The department I'm heading, the research area I'm heading, is the electromechanical engineering. I have brought another slide, so I will skip this here at the moment. We've got a research area which is about data and power networks. So it came from classical car harnesses, but is now looking also at other processes where we have automated handling and inspection of so-called linear deformable objects. Our department for home automation is more into the energy production, storage, and intelligent and safe living. And if you look at the blue groups, these are 4 groups which are located in Erlangen. So sorry, I forget to mention that. We've got 2 sites. One side is Nuremberg with the green groups, and the blue groups are in Erlangen, where we're doing medical technology because we have got a big medical valley in Erlangen. For example, we're doing mechatronic implantats, but also the automation and the digitalization of hospitals are a point here. In our robotics department, we are not even using robotics like in the other research areas, but we are researching on them. For example, we are working on mobile robots, on personal robots, but also new crippling technologies, or even new robot kinematics, like I think everybody knows from big football stadiums, the cameras, which are on 4 wires, which can go down to the field level of the football field. And we are building up some robots which have same kinematics. And the 2 remaining groups are our digitalization groups, where we can digitalize the whole factory, starting from the process over digital twins up to the whole factory, where we can simulate how to produce things and to scale the processes. So last slide about this last slide about what we are doing. In my research area, we are focused on the production technologies for electric machines. So I just pictured here the charging pad, but we also having a lot of projects which are about electric motors. And what we are doing there is the research, mainly the research on production technologies like assembly technologies, joining technologies, or forming processes. We are, but also focusing on recycling, especially in magnetic things at the moment. We're having a big measurement laboratory where we can measure a lot of different properties of the produce we are producing. We are researching on data-driven process optimization. So, for example, machine learning while winding or by laying bit wires on a product. And of course, process simulation is very important. And we're looking on every single part which is included. So conductor materials, soft magnetic materials, dielectric or insulating materials are in the focus. And therefore, we have got a laboratory, which you can see here. We have got about 2,000 square meters of laboratory where we have a lot of machineries where we are able to produce this electric machines. Okay, so that's it for the short introduction of our institute, what we're doing. I also brought you, and I think you all know the numbers and the motivation about electric roads, but I just brought you a slide from the EU. We have got this zero emission strategy for cars, which will start at least 2035, when we don't want to have new combustion engine cars. Why? You can see it in the slide. If you have a look on the transport emissions in the EU, you can see that almost more than 70% of them are caused by road transportation, and they're about 60% per cars, but also about 30% in the heavy duty trucks and about 10% in light duty trucks. So transportation produces a lot of CO2, and we have to get rid of them with the European Union plan to ban combustion vehicles in 2035. So that's why we need alternatives, and from our side, electric roadways are one alternative, and from our side, as of course mechanical engineers. Sorry for that, I forgot the slide. Sorry, just remind my last sentence. Also some facts from the European Union. We have a core network, so you can see here the Europe, and we have got a core street network, not all streets, but the most important streets, and the length is about 50,000 kilometers. We have, of course, a large number of manufacturers for cars, but also for trucks. And we have several pilots running here, as well as in the US or in the whole world. So I think you might know the Electron projects in Gotland, but they also have a test track in Karlsruhe. Stellantis in Italy built up ERS, I think last year or the year before last year. And we have the Fabric project in France with 100 meters, and in a real laboratory of the Federal Highway Research Institute of Germany, we have currently also 3 real laboratories running. So that brings me to this slide. For us as mechanical engineers, we are focused on the production process, and we think that this production process is very important for the technology as well. I just brought you a slide. Maybe you know some of the process, maybe not all, maybe every process is new for you. So that's why I brought the slide, which shows the essential processes here. It starts with the winding of the flat coils. You can see here in the picture on the top left. We have to develop kinematic concepts, machine implementation, and also the Litz wire termination. We have to contact the ends of the Litz wires. There are different processes, for example, hot crimping, ultrasonic crimping, but also laser beam welding. In case we need it, we have to assemble ferrets on the system. Therefore, we need positioning strategies. We need handling and gripping systems for this materials, and of course, we also need measurement systems. We have to integrate the compensation with different technologies like surface-mounted devices or DHTs, even film capacitors or ceramic capacitors. We have to house and pot the system. So we need conductor insulation or a vacuum potting or impregnation. And of course, we have got different end-of-line tests. This is just the system, the electric system. And of course, we have to integrate this into infrastructure. For example, in concretes on the left side, you might know this picture maybe, but also on the street with different laying processes, and even with, I think, Electrium concepted this picture here with an automated and scalable integration process of the modules. So what we did and what we are doing is on this slide. I brought another slide for the last 3 projects or the last 4 projects. What I want to tell you that we started to work on this technology in the early 2000s with a first funded project. It was a study, a feasibility study, where we worked together in 2010 and with really the who is who of companies in the German industry. For example, Bosch, Siemens, Audi. We brought in a construction company, Max Bögel, and our mission was to say, dear German automotive industry, dear German people, wireless charging of electric car is visible. The results were quite good, but the market wasn't at this moment. But we already did a second project that was founded by company network here in Bavaria, the first E-road project, where we developed the feasibility of how to produce electric road systems. The next 3 projects I brought on the next slide. So we started to in 2017 to continue with the research on the production of coil systems and of infrastructure systems, and our vision is to start next year with a so-called E-road center, which should kind of enable the technology for the market. So what we did in the last 4 to 5 years was a project on stationary charging called E-Profil. It was on the efficient processes for manufacturing inductive charging systems. We worked here together with Bosch, with Solner, which is also a system builder, and Leonie, which is a cable manufacturer. And we developed on the one hand a concept which is more easy to manufacture. It was for stationary charging up to 11 kilowatts. We developed a novel process change with innovative processes. We optimized these semi-finished products, and we tried to increase with this technology the transmission efficiency with automated processes. In a second project, which is currently running and which goes into a pilot within the next months, is the E-road project, which is about manufacturing processes of the primary side coil modules for electrified roads, and in this case with concrete technology. We worked together with Wheel-E, which is responsible for the design. We worked together with the University of Dresden, which is responsible for the construction process or research on the construction processes in roads. We worked together with Stelcon and ORT, which is responsible for the concrete, and a BAST, which is doing tests on the Dura-Plast pilot. So this is for semi-dynamic charging up to 22 kilowatts. It's also on the automation of the production processes, and especially in the integration of coils into fixed and big concrete elements. And we want to build up a construction of about 50 meters test pilot. And the last project, which started about 1.5 years ago, is about fully dynamic charging. So it's called EM-Power, which is for automated manufacturing processes for electric road systems in asphalt construction in this way, and also for heavy duty. So dynamic charging for up to 44 kilowatts. We're working there together with Electrion, and of course with the Electrion design. Risomat is one of the players who is responsible for winding processes. VIA IMC is a construction company which is responsible for the processes of integrating the modules into asphalt and also to digitalize these processes. And we as Institute FABs are responsible for scaling the process trains and also automating the road construction. And another institute from another university or technical university in Nuremberg is responsible for electric and grid, no, not grid, power simulations. And in this project, our plan is to build up a kilometer of test track on a fully public highway in Germany, which can be seen by everyone who is kind of passing this highway. So for the future, I already mentioned our big vision is that we want to get all the research which is done at our institute, but also on a lot of other institutes and in a lot of other consortia in Germany as well as in Europe, in a kind of e-road center, and kind of make this technology ready, usable for the broad communities. So we are at the moment concepting a so-called e-road center, where we working on a consortia of different companies and universities, which a lot of already signed LOEs and got some funding. Don't get the English word, promises. We're funding promises from the Bavarian government, and we are hoping to maybe start this within the next 12 months. And what we also did is to transfer this new challenges to our students, and maybe this is also interesting if we are talking about a potential cooperation or integration in the Aspire network and a potential exchange of students. So we did an international degree program for undergraduate and graduated students, which is called Electromobility ACES, and which is focusing on A for AI and autonomous driving, which is and of course autonomous charging, which is part of which is important for the topic. Also connectivity, where we are addressing vehicle and infrastructures, networks, smart grids, with e-powertrains, of course, charging technologies, energy storage, and will be interesting here. And of course, S for sustainable mobility and sustainable production technology, which is also very important and also for this technology. So to sum it up, in this case, we are at the moment trying to get all the small and bigger research projects in a lot of different states and countries of Europe together. We have got already some pilots, not only in the US or in New Zealand or in Korea or something like that, but also in Germany or in Europe. And in this at our e-road center, we want to bring all this consortia together and all these companies and universities to kind of improve the quality of life through sustainable and clean mobility. And I think maybe what we can say, we have kind of same mission, we have kind of same vision. And so our idea, and that's where I'm very happy to present here our research as well, is to cooperate with you guys and maybe to be part of the Aspire network as another additional international campus. So that's it from my side. Thanks for the attention, and thanks again, Don and Regan, for the possibility of presenting here in the Tech Talks. And
well,
yeah,
thank
feel
you
free to ask some questions. I think a few members of my team are also here.
Very good. Thank you, Alex. And we know it's a great partner when your partner can stay up till 10 p.m. to give a presentation. So appreciate you doing that. We would like to open the call up now for questions from our participants. If you have a question, please take your phone off mute, introduce yourself and your organization, and ask a question. If you're not asking a question, we do ask you to keep your phones on mute. You can also put questions into the chat, and I can moderate that for what's coming across the chat. So please go ahead. Sorry, I thought someone was asking a question. Any questions? I do have a question. Maybe I could start with Alex. We talk a lot about standards, and you're obviously in the European community. How are you working across European standards, and how do those actually reconcile into kind of the global standards, or what you would think as global standards?
Unfortunately, I think I'm not the right guy to answer this. We are only kind of consumers of standards, but we are currently not working in. So we as university, as FAU, are currently just consuming and reading the standards and not currently working actively on standards. We just made a plan with Electrion, maybe to work on standardization of stationary, dynamic charging, but only in kind of system and production technologies. So I'm unfortunately can't say there are a lot of things too.
Again, if anyone has a question, please take your phone off mute.
Hello, I have a question. I'm Matt Jones, a mechanical engineer at Aspire. So I'm wondering how to decide how efficient is efficient enough, or how automated is automated enough. I feel like you could endlessly improve or endlessly make something more efficient. How do you decide when something is good enough? Are you given criteria beforehand from I don't know, construction companies or factories, or do you just start with the easiest and work your way down until you're out of time and money, or what is your strategy there?
So if you're looking on, for example, the production of this mechatronic product, this charging pad, if you want to sell it, someone have to pay for it, and so our one way of optimization of production process is to make it more cost efficient. Another way is to make it from better quality. So for example, you can say, okay, we have got hand wound, manual wound product, the manual crimped or soldered connection, and we can see now in this product we have got resistances of, I don't know, contact resistance of 2 milliohms, which causes this losses, and then we can try to optimize the connection process with other parameters or even other processes to reduce losses in kind of things. When you have a look on the winding process, of course you can produce a pad per hand, which will take you this and this time, which will cost you this and this, but you can also try to have a big kinematic to produce much flexible different pad designs, but maybe they are really slow, and so it takes also a lot of time. And if you need more products, so you scale up your production, you need to develop special machineries and special processes for the optimization of the production of the pad. So this is what we are focusing on.
Maybe, if I may, I can add a second aspect, perspective on this. there's one thing that we try to automate, especially in the Empower project, which is the construction process, or especially the deployment process of the coils and the resonant circuits into the roads. And there we have quite harsh criteria, as there are already established processes for the road construction sites, which have a certain amount of kilometers or miles per, let's say, day or night shift that can be achieved during a certain time. And we do not want to slow down these partially automated processes, so that it does not take longer if we are planning to implement our systems into the roads, into the Autobahn, as it already takes for a new construction or a renewment of the road.
I see. Yes. Okay, that's very helpful. Thank you.
Thank you. We have a question from Tyler Wunsch.
Yeah, hey there, Tyler Wunsch from MUD, the Sacramento Municipal Utility District. Really interesting presentation, and the question I have is more about deployment, where right now in the U.S. there's about 30 cities that have light rail systems. I think globally, with like subway, metro, there's about 195 cities that have a metro system. And so what I'm thinking about is deployment of these systems. And so, airports, transit agencies, private freight, just curious where you see the first deployments happening in the wild, and where sort of as a utility, where we could think about that, but also help. I mean, Sacramento has high pollution from transportation. There's some accessibility issues with folks who don't necessarily have cars, and so the transit agency, SAC-RT, is definitely very innovative and progressive in looking at this. So yeah, just kind of wondering from a utility standpoint where you see deployments happening first.
Okay, so what we are addressing, or what our governments are addressing at the moment are
be open. Yep.
Sorry.
Yeah, it could be open-ended. So for you, for government, or where?
Yeah. I just got the question. So what our government is looking for at the moment is the solution for the electrification of heavy duty transports. So we are at the moment as not focusing on cities, or even not on private vehicles, because Germany is not that big as the US. So I think it's easy to reach every city in Germany by car, even with a Tesla 3 or ID4 or something like that, with only one charging stop. So what we are at the moment addressing mostly is a solution for heavy duty transport, and what we are at the moment building is what our projects are currently running in this solution for the electrification of heavy duty. So I think maybe electrification of this key network of streets of the EU I presented would be an approach to say, okay, we are trying to charge commercial vehicles during driving to reduce charging problems at the parking lots, to reduce battery sizes, to rise the option to transport more things, because if you have got big batteries, you can't put a lot of stuff into your trucks. This is something which might be a kind of starting point to enable this technology for public or the transportation sector, and then also for, of course, cars, but more off city and not in cities.
Okay.
Thank you. Thanks. We have a question from Doug Wilson from the University of Auckland, New Zealand. He says, I would like to ask, what is the main source of your funding for research? Is it largely German government, private industry, or European framework funding sources? That's from
Yeah. So all the biggest 3 projects I mentioned are funded by the German Ministry of Economics, BMWK. The E-Road Center project I addressed, maybe, we hope it could be funded by Bavarian state. We also made some contacts to the European Commission, and what we know is that there is a kind of deciding process going on at the moment. They know a lot of different technologies like hydrogen, better place, battery concepts or something like that, and they want to decide in the next months or years what they will focus on. And so there's at the moment no funding for pilots or some technology development in any of these technologies. Hope this answers the questions.
And if you have a question, please take your microphone off mute.
Don, is it okay if I ask another?
Sure.
Okay, great. So I'm still Matt Jones from Aspire, so a lot of this technology is still quite young, and it's still improving very quickly. And I know that some of the projects that I am working on, but by the time I finish a project, then the next project has advanced in technology, and it looks quite different from the last one. Is that a challenge with you with trying to automate these processes that are changing so quickly?
It depends. So we come from the electric motor, and even the electric motors are very old technology, but because of electromobility, automotive manufacturers, there have been a lot of new designs, even new technologies, and where we have to think about new production technologies. And I think that's kind of similar to if we have a new development in a pet design or something like that. Usually you have got something which is doing the electromagnetic field. This is usually a Litz wire at the moment, and usually you have to connect it to something, and maybe this one is bigger or smaller or something like that, but the fundamental processes are quite the same. Sometimes it's only process adaptation for a new product. Sometimes you have got, of course, maybe you don't have a circular coil, but you have got a double D coil or something like that. So you have to adapt the way of how to wind or how to lay down the windings. You can have other requirements because maybe standardization says, okay, higher temperatures, you need other resins or something like that. Of course, it's a challenge, but it won't be so interesting if there are no challenges, I think.
Right. Right. So do you focus more heavily on automating things that are unlikely to change very much, because you know that this process is more set or unlikely to be improved?
Can you
Instead of
repeat
having
this?
to.
I didn't get it. I get it acoustically, but I didn't understand the question.
Okay. So you said that some aspects maybe change, like the shape of the coil, for example. Other things do not change very much. Do you focus more time and effort on things that do not change very much, so that you don't have to redo your work, so to say?
Yeah. Of course, in these cases which don't change a lot, we can do a little bit more fundamental research, which is good, for example, PhD students who want to maybe do a big test, big study. But on the other hand, I think we don't prioritize. Sorry, I don't. We don't say this one is better or this one is better. It's just other ways to address these challenges. But I think Michael, which is also from my team, just unmuted and that's something.
Yeah, exactly. That's a very important question. We are focusing on the one hand on the production technologies themselves, something like how to make good contact points, how to have low transient resistance, how to encapsulate our systems in that a way that it's not affected by environmental conditions and is able to be integrated into roads or into concrete or whatever. And this, of course, are fundamentally more generalistic things that we are doing our research on. Of course, if we are building up for a large scale production, we have to someone invest into forms and potting systems, etc., that are only for this layout and that system. But at the most of the time, we're doing our research on the fundamentals. So I do not think that there's a big discrepancy between these two aspects. And the industrialization itself is always more or less a validation for our production technologies.
Right. Okay, wonderful. Thank you very much. That answered my question.
Thanks for the question.
Any last question? You have time for one more. If not, thank you, Alex and your team for that presentation. Regan, would you like to say something?
Just a final thank you, Alex. Great presentation, and really look forward to working more with your team. As was mentioned, we're looking at opportunities for student exchanges between the programs and additional opportunities for collaboration. So it's going to be great to work together, and appreciate the highlights here, Alex.
Yeah, thanks again. We're also looking forward to nice opportunities.
Thank you all for joining our Tech Talk today. Our next talk will be on November 15th. We will send out shortly what that will be, but we're looking forward to possibly one of our new members talking about their technologies and some of the problems that they're looking to solve. Appreciate your time today. This Tech Talk will be available on our website once it's posted, and thank you and have a good day.
Thank you very much.